Hello, everybody. Today, I'd like to introduce you to Finwave Semiconductor, a startup that's working on gallium nitride on silicon technology that has great potential for improving the power efficiency of high performance 5G and future 6G equipment. It's my pleasure today to be speaking with the CEO of the company, Pierre-Yves Lesaicherre. And so, with that, let's begin. Could you introduce yourself and the company?
Yes, so my name is Pierre-Yves Lesaicherre. I'm the CEO of Finwave Semiconductor, and we're a startup focusing on gallium nitride on silicon. So GaN-on-Silicon technology for RF communications on the infrastructure side as well as on the cell phone side.
Okay, and I understand your company has just closed a round of funding. Could you tell us about this latest round, the investors, and kind of the business proposition of why invest in this kind of company at this point in time?
Okay, so the round we just closed, we just announced it today, is for $8.2 million in funding. We have three lead investors: Fine Structure Ventures out of Boston, it's part of the Fidelity Group; Engine Ventures, very connected to MIT, also in Boston; and then Safar Partners, also in Boston. So East Coast venture capital firms. We also have GlobalFoundries as one of our strategic investors who also put some funding into this round. This is very significant, and the reason why these companies, these venture capital funds, are funding us is because they see the GaN-on-Silicon technology emerging as a true alternative to existing technologies, both in infrastructure and in cell phones, for both power amplifiers and RF switches. So existing technology in the cell phone for the power amplifier is gallium arsenide, and gallium arsenide is starting to run out of steam as frequencies go up, and the need for higher power efficiency at higher frequencies is required. Gallium nitride is a perfect replacement for gallium arsenide. In infrastructure today, the incumbent technologies there is already gallium nitride, but it's mostly on silicon carbide wafers, so what we call GaN-on-SiC. With the emergence of GaN-on-Silicon, we have the ability to replace GaN-on-Silicon carbide at a lower price point, obviously, still having a very good performance.
Okay, so can you perhaps walk us through some of the history behind the GaN-on-Silicon technology? It sounds like there is a moment of innovation that's happening here, but I know we have been talking about GaN for quite some time, and it seems that many of the industry giants are already playing in that space.
Yes, GaN-on-Silicon carbide is already being utilized in infrastructure. But it's expensive. It's built on 4-inch, 6-inch wafers, silicon carbide wafers. It's quite expensive, but it delivers pretty good performance. The emergence of GaN-on-Silicon is linked to the advancement in the technology itself. So Finwave was founded in 2012, so 13 years ago. And for the best part of 10 years, we've been working on that technology, refining it, figuring out the right epitaxial structures, understanding the process technology, and developing various device architectures. So the particular technologies we've developed, either for infrastructure or for cell phone, took quite a while to develop. We have now demonstrated on 6-inch and 8-inch wafers that they're very, very applicable to the future trends of both infrastructure and cell phone as we move towards 6G. Higher frequencies, in particular, anything above 5 to 6 gigahertz. So in cell phones and in infrastructure, you will see FR3 coming in the 7, 8 gigahertz, and then maybe another band in the 13 to 15 gigahertz. And in these frequencies, gallium nitride has the much better performance than existing technologies. What has taken so much time is really the maturing of the technology. It took time to develop the technology. It's the development research time.
Okay, and to move to the next step, then, are you working with foundries in particular to roll this out, and what's required on the sort of their end in order to commercialize?
Yes, so we have 3 sets of technologies that we have developed over time. The first product we're launching to market, they're actually available for sale now, are RF switches, high performance RF switches, high power RF switches, so 10 watts, 20 watt, 30 watt continuous power, so very significant high power switches that can operate at high frequency with a wide band. They can operate from a few kilohertz to 12 gigahertz. So very unique switches. We have a partner in Taiwan with whom we've co-developed that technology. So we're manufacturing that in Taiwan. The second technology we're working on is power amplifiers for infrastructure. It's a different technology. We're also working with our partner in Taiwan, and we're going to have products by the end of this year. And then the third very important technology, which has received a lot of press, is we've developed a unique architecture called a MISFET or MISHAPT. So it's a metal insulator semiconductor, replicating kind of what you have with a MOSFET, but this time it's a MISFET. It's not an oxide, it's an insulator. And with that technology, we've demonstrated very, very strong power efficiency. And this is particularly applicable to cell phones. It's a 5-volt GaN-on-Silicon technology. And for that, we're working with GlobalFoundries. So we've announced the partnership with GlobalFoundries last year, and then they're part of the funding round this time. So and we're co-developing, we're transferring the technology and co-developing at the same time.
Excellent. Excellent. Anything else that you'd like to highlight in terms of industry momentum or critical IP or patents that your company
we have a lot of technology. As I said, we spent the most part of the last 10 years, 12 years developing the technology. And as we went along, we took a lot of patents on the epi structure, on the process technology, on the device architecture. So this technology is very well patented and protected. I think, the next 2-3 years, we'll see a very strong adoption of GaN-on-Silicon as we release products. In switches, we're kind of an extension of RF-SOI into higher power. And in infrastructure, as I said, our intent is to displace GaN-on-Silicon carbide, especially as the architecture moves towards multiple antennas, the 64, 124, 256 antennas architecture. The requirement for the power amplifier for each antenna has come down. Instead of having a very large antenna and very high power amplifier, you've got multiple antennas. So the requirement for the power amplifier is in a couple watts, which is perfect for GaN-on-Silicon. And we can do that at very high efficiency and relatively low cost. So I think the change in the architecture in infrastructure, as well as our progress on developing that technology, makes a perfect convergence where the technology will start ramping up in production and being adopted by customers.
Excellent. Well, congratulations on the funding.
Yeah, thank you very much.